Hey, Johnny Vanford here, Lorain County Community College MEMS and Microelectronics Manufacturing Program, as well as Merit Manufacturing Electronics and Rework Institute for Training. We actually have a company that's in town right now that's trying to do some training for printed circuit board manufacturing, and we are preparing for the last part of the training session tomorrow, which includes building a printed circuit board. One of the printed circuit boards that actually was built by our students as of last year is this guy that's right over here, which is kind of a Simon-based memory game that comes in 2x3 panel that they built. And the trainees were like, oh, that's cool. These are folks who are new to printed circuit board manufacturing, who prior to stepping into the room, most of them had a limited amount of soldering experience, and we wanted to help them get some additional experience with soldering of through-hole components, soldering of surface mount components, and experience on our SMT line, which has a whole bunch of things that we want to teach them. But one of the things that we're going to be focusing on is the pick and places system, our Panasonic NPM-W2's unique feature, which is able to scan in a fiducia to determine whether or not a part has been placed inside of the machine incorrectly. So on this circuit board is a QFN chip. This is actually an AT-Tiny85 automotive microcontroller that we have programmed in a simple game on it for pedagogical purposes. And this is actually loaded in via a tray, but the tray is loaded into the system, and then when it has the part that is picked up by the vacuum pickup tool, the camera that's in there actually scans it to check for a fiducial to see where the part is. And if it doesn't see the fiducial, it knows to don't put that part down. And after so many times of doing that, it says, okay, so I think the part's in the wrong order. I'm not programmed correctly. So let's check this out. So let me come on in here. Zoom in onto the programming screen here. Let's see, there we go. Okay, so that's the Panasonic programming screen. It's on both sides of here. We're going to go to the back of our table here, which is table 2, and we're going to go to our trays, and we're just going to check to make sure that the part is reset at position 1-1. I have one part in there in the correct orientation right now. Now what I'm going to do is I'm going to go and pick up that part. So that part is the AT-Tiny85-20 MUR. It's 20-pin. It's a 20 or 24-pin. 20-pin QFN package. And I'm going to go tell it to go and pick it up. Now, what the machine is going to do is the back end pickup head is going to go and scan all 6 areas to figure out where the origin of the part is. So let me try. What I'm going to try and do here is get you a little bit closer, kind of a view from here. So it's actually already got the part, and it's scanning the pickup head. Now it's going to go and actually go and pick up the part. The first one it picks up, it actually checks to make sure that the part is then put in correctly by doing a height check. Now it has just picked up the part, and it is holding it right now in the pickup tip. So that is the pickup tip. The nozzle is actually holding in the part in the back of the system that's right there. And now what we're going to do is test it. So we're going to test this part. And we can see here that if I blow up the screen really big and we zoom in very carefully, that this QFN chip, which has 25 pins or 20 pins going all around, also has an additional notch there. And if we look very, very closely, there's a little square that has been programmed into that exact position to say that area should be dark in comparison to its surrounding area, which is actually bright metal in its color. So now we have an idea that this machine sees the fiducia here, but the question is, can it recognize when it doesn't have that part? So I'm going to tell it to escape from here, go ahead and return that chip back to the original part so we can do a test on it again, pull the chip out, and actually show that this chip can be swapped around and actually checked in for its orientation within the machine, which is useful for JEDEC trays because so often we have JEDEC trays that sometimes have to be manipulated in particular ways where the chips have to be put inside, or we just want to check to make sure that the chips that came from the manufacturer actually were put inside in the correct way with it here. So one of the things that we're going to do is we are going to remove the tray on the machine here. That actually comes out via this little tray slot that's over here. There we go. There's my JEDEC tray.
And right at the corner there is my chip. All right. What I'm going to do is I'm going to take a pair of tweezers here, and hopefully be able to do this on camera. Let's open this up here. I'm going to rotate the chip 90 degrees and place the chip back into the slot here. So that goes back inside. Close the door, lock the system. Tell the system here that it's okay to confirm that all the pallets are actually on the inside of the system there. The tray gets dragged back in. All right. And now what we're going to do is head back over to the testing area for the parts test pickup spot and see if we can't pick up this part. First, we'll check to make sure that the part is actually been reset to the original 1-1 position. Sometimes the machine likes to go to the next part over after we put the part back. So just a good double check here. Go to the trays, and it is indeed in the 1-1 position. Now we're going to go and actually test the part here. Tell it to go and pick up the part again. So the machine checks the position of the nozzle that's on there. It goes down. It's grabbing the tray as of right now, pulling the tray out and forward. And the machine is now checking to make sure that the height of that part is correct for the first one that it is picking up. Come back over to the screen here while it picks up the chip. Chip has been picked up. One of those things you can just kind of hear. That there. And now what we're going to do is test it. And, we can see here that, I actually hit the help button with it. You can see here that it has come back with a recognition error at this point here. That is because I've rotated the chip with notch to a polar 90 degrees positive, and the marking that's on here is too much white on the inside of it. So the actual square marking that's over here is too much white on the inside. That's because the notch is over here. If this chip error were to occur 3 times or more in a row, what the machine would do is stop the manufacturing process and alert the operator, technician, engineer that there is a problem with the chip, which is exactly what we wanted to do, especially with the chip shortage being what it is. We don't want to just throw chips out, especially expensive chips like this microcontroller compared to passive components. So we want to be able to preserve that. That feature is really useful on pick-and-place systems to have a recognition feature. And it's something that we're actually going to be telling the technicians tomorrow to encourage folks to look out for it, because if it can spot it here, it can fix the problem here. Less rework is required down the line. Less supply parts are lost in the process with it, which is really what we want to have happen with that. Let's turn the chip back to its tray, please, so that we can install this tomorrow, manufacture this on the tools. All in Lorain County Community College's MEMS and Microelectronics Manufacturing Program, as well as Merit Manufacturing, Electronic, and Rework Institute for Training. Please leave a comment down below what you think about this video. Check out more videos on my YouTube page, and we'll see you around on the next one, folks. See you later. Bye-bye.